In this video, we're going to look at sequences again and determine if a sequence represents a linear or nonlinear function. If the sequence represents a linear function, then we are going to construct the equation to represent that function. To be a linear, the sequence must have the same common difference between each term. Remember from the previous video, to find the common difference, we took our next term and we subtracted it from our previous term. So let's look at example A. We have a sequence with the terms 1, 3, 5. So the first thing we're going to do is we're going to check to see if it's linear. So to do that, we're going to take our next minus our previous. So we have 3 minus 1, because this would be our first term and this would be our second term. So we're going to have 3 minus 1, which equals 2. Then we're going to test again. Remember, we have to test all of our terms. 5 minus 3, which equals 2. So this, your common difference, is the same, so we know that it's linear. So this sequence has a common difference of 2. So now we want to create an equation to represent this linear function. And so we're going to be looking at kind of this formula. And so our formula to write our equation is going to be f of x equaling the common difference times x, which is going to be our variable, plus this 0 term. In our 0 term, right now, this is our unknown. And so the 0 term is saying, well, what's the term that comes before the first term? Because here, to get from one term to the next, we're adding 2 each time. But we want to know what happens if 1 becomes our next term. What is the term before it, previous? So if we want to think about it, we have the 0 term, then we have 1 being our first term, 3 being our second term, and 5 being our third term. So first, second, third. So we have to kind of work backwards. So here's our first, and we want to know what that 0 term is. So think about our formula here. The common difference is next minus previous. We know the common difference is 2. Then you have your next term and your previous term. So your next term is the first term, which is 1, minus this 0 term, which we don't know. So I'm going to call it z for 0 term. So 2 is our common difference, 1 is our next term, and 0 term is the previous. So we want to solve for this z. So we're going to solve an equation using opposite operations. We're going to minus 1 from both sides. So 2 minus 1 is 1. The 1 and the negative 1 cancel out, and that would be equal to the negative of the 0 term. Well, we want to know what the positive of the 0 term is. So we're going to multiply both sides by negative 1. 1 times negative 1 is negative 1. And negative z times negative 1 would equal positive z. So your sequence starts at negative 1, and you can check it. If this is negative 1, and I add 2 to it, will I get to positive 1? And the answer is yes. So if I'm going to write my formula, I now know my unknown. So I have f of x in function notation equals the common difference, which we solved to be 2, times x plus the zero term, which is negative 1. Or you could write it as f of x equaling 2x minus 1. With having this equation now, we can find the value of any term number. So x would represent your term number, so we could plug in 5 and we could find, well, what is the 5th term in the sequence? Or we could plug in 100 for x and we could solve for the 100th term in the sequence. All right, let's look at example B. So we have 21, 27, 33, 29, 45. So first we need to check to see if it's linear. So next minus previous, we're going to have 27 minus 21, which would equal 6. We would have 33 minus 27, which would equal 6. 29 minus 33, which would equal negative 4. So right there is an indication it's not the same for the common difference, but we're going to check the last one just because what if you skipped this one, which we know we shouldn't do. We need to test all of them. So 45 minus 29 would equal 16. So you could also catch it there. So in this example, there's no common difference. Therefore, the sequence does not represent a linear function so we cannot form an equation. So if it's linear, then we move on to the steps we did above in finding the equation. If it's nonlinear, then you are finished with the problem. We can't create an equation, a linear equation from a nonlinear sequence. All right, let's look at example C. The sequence given to us is 10, 14, 18, 22. So the first thing we're going to do is we're going to check to see if it's linear. So we have 14 minus 10, which gives us 4. We have 18 minus 14, which gives us 4. And last check, 22 minus 18 equals 4. So all of these have the same common difference, so therefore it represents a linear sequence. So we have a linear sequence with the common difference of 4. So now we want to create that equation. So our equation we're going to be looking for is f of x equaling the common difference times x plus that zero term. All right, so that zero term is our unknown. It's, well, what if we go back a step? So we know that 10 is our first term in our sequence. We want to go back a step and find, well, where would the zero term be at? So all of these, we are adding 4 to get to the next term. So if 10 is the next term, then we need to know, well, what would be here if we add 4, we could get to 10? Or, obviously, you do what's opposite if you're working backwards, then we would minus 4. Or we would think about it in the terms of our common difference equaling that next minus our previous. We've concluded our common difference is 4. Our next term is 10, which is our first term, minus that previous term, which we're solving for, which is that 0 term. So we would minus 10 over. 4 minus 10 would be negative 6. 10 minus 10 would cancel out, and you have negative z, or that negative 0 term. Well, we want to know what the positive of that is, so we're going to times everything by negative 1. So negative 6 times negative 1 is positive 6, and negative z times negative 1 would be a positive z. So our 0 term is 6, and you can check it. 6 plus 4 would give you 10. So our equation would be f of x equaling 4x plus 6. And this equation, again, would allow us to find other terms in the sequence. All right. Let's look at example D now. We have the sequence negative 3, negative 6, negative 9, and negative 12. So first, we're going to check to see if it's linear. Next minus previous, so you're going to have negative 6 minus negative 3. So 2 negatives become a positive, and that would be negative 3. The next one, negative 9 minus a negative 6. 2 negatives become a positive, negative 3. And the last one, negative 12 minus a negative 9. 2 negatives become a positive, and you have negative 3. So the common difference, I'm just going to abbreviate it as CD, is negative 3, because all of these are the same. So we can conclude that it is linear. Now for our formula. Again, we have to think backwards. What do we need to do to find that 0 term, knowing that negative 3 is our first term? So the common difference is found by next minus previous. We've concluded that negative 3 is the common difference. Our next term would be negative 3, which represents our first term, and we are solving for the 0 term, which is our unknown. To get this by itself, we're going to use opposite operations, so we're going to add 3 over. Negative 3 plus 3 is 0. Negative 3 plus 3 is 0, so those cancel out, minus z. So 0 equals negative z. Again, we want the positive of it, so we're going to times everything by negative 1, and 0 times negative 1 would be 0, and negative z times negative 1 would be positive z. So our equation would be f of x equaling negative 3x plus 0, or f of x equals negative 3x. Now, I'm going to show you another way of how we can look at this problem. Because when we think linear, we might think that we could see a table of values instead of a sequence. So now we're going to represent our sequence in terms of a t-chart. So here's our t-chart. And so now let's think about what these all represent. So negative 3, negative 6, negative 9, negative 12 represent a value in a sequence, and the value is what the term is. So here we're going to have the term number and the value of that term. So the first term has a value of negative 3 in your sequence, the second term has a value of -6, the third term has a value of -9, and the fourth term has a value of -12. And so, again, we know the common difference is -3 from the next minus the previous, and you can also find that from the table of values, just going -6 minus -3, -9 minus -6, and -12 minus -9. Table of values is a little bit more difficult to see the common difference because you have to check both your first column and second column to see how they're changing, and we're changing by 1s for our terms, and then we're changing by -3s for our values. A linear function, as we know, has the equation y equals mx plus b, where m represents the slope, and the slope is our common difference, how we're moving from one term to the next. B represents the y-intercept, or as we have been calling it, the zero term. So we can plug in and actually solve for our b value knowing one term in our table of values. So we're going to select one, 4 and -12. So 4 represents our x. It's our input. We're inputting the term number and we're outputting the value that it's worth, -12. So -12 is y. M is the slope or the common difference, and of our sequence we said is changing by -3. Our x is 4, it's the fourth term in the sequence, and we want to solve for b. So -12 equals -3 times 4, which would be -12 plus b. We want to get b by itself, so we're going to add 12 to both sides. -12 plus 12 would be 0. -12 plus 12 cancels out, isolating b, and so b is 0. So both methods give you the same equation, y equals -3x plus 0, or y equals -3x. One is in function notation and one is in our slope-intercept form. We have one more example to look through. We have the sequence 15, 12, 10, 9. So the first thing we're going to do is we're going to check to see if it's linear. So we have 12 minus 15, which is -3. We have 10 minus 12, which would be -2, and 9 minus 10, which would be -1. So these are not the same, so there is no common difference. And if there is no common difference, the sequence is non-linear, so we cannot form an equation.